Lesson 11 asks us to compare ratios using ratio tables. So we're going to begin in example 1 by creating 4 equivalent ratios, 2 by scaling up and 2 by scaling down, using the ratio 30 to 80. Scaling up and scaling down simply means to make ratios that are larger by multiplying both numbers by the same number, or by making them smaller, scaling down, by dividing both numbers by the same number. So we'll start off by scaling up. That's something we've done many times over. If we have the ratio 30/80ths, we can scale up by multiplying both 30 and 80 by 2, which would give us 60/160ths. And then we could make another equivalent ratio by multiplying both 30 and 80 by 3, and that would give us 90/240ths. Next, we would look for 2 ratios that we can scale down, and 30 and 80 I know are both divisible by 10, so I could divide both by 10, which would give me 3/8. And then I could also divide both by 5. And if I divided both of them by 5, 30 divided by 5 would be 6, and 80 divided by 5 would be 16. Moving along, the ratio relationship in the table, as you can see, is 2 to 16, or simplified could be 1/8. And that's all they ask for that table, just so that you describe the ratio from the table, and you can also simplify it. Exercise 1 is comparing the texting rates of 3 different people, Michaela, Jenna, and Maria. In order for us to compare their rates, though, we need to know how many words they text in 1 minute. So what we're going to do is take the words and divide by the number of minutes from the table. So Michaela can text 150 words in 3 minutes. There's the ratio, and that's also a division problem. So 150 divided by 3 is 50 words per minute. Jenna can text 90 words in 2 minutes. So 90 divided by 2 would be 45 words per minute. And finally, Maria can text 120 words in 3 minutes. And when we divide that, we get 40 words per minute. Now, when we compare their actual rates, we can see that Michaela can text the fastest, 50 words per minute. They ask us as an extension now to complete a table for Max, whose texting rate is 55 words per minute. That would mean then that Max can text 55 words in 1 minute. Then we can extend the table. If he's texting for 2 minutes, Max should be able to text 110 words. If he texts for 3 minutes, he should be able to text 165 minutes. And finally, when he texts for 4 minutes, he should be texting 220 words. Exercise 2 has some juice mixtures that 3 people have put together, and they have added different amounts of water and juice concentrate. So what we need to do is to put the juices in order from the most water to the juice containing the least water. There are a variety of different ways we can do this, but for the ease of this exercise, I'm going to take the water to juice ratio and simplify that, divide it just like we did in the last. So in Laredo's juice, he had 12 parts of water to 4 parts of juice. And when we divide that, we find 3 to 1, a 3 to 1 ratio. Franca's juice is 10 parts of water to 2 parts of juice. And when we divide those, we get a concentration of 4 parts of water. And finally, Milton has 8 parts water to 2 parts juice, which when we divide is a 4-to-1 ratio. Now, since we were looking at water to juice concentrations, because that is what they've asked us to do, the greatest water to juice concentrate, then we look for the greatest number in our selection, which would be Franca. We have Franca's, the second would be Milton's, and the third would be Laredo's. Your explanation should describe what you chose to make as your ratio, as well as how you did the process of dividing, what ratio was used to create each table. Again, would be what you put there. We could have done the work down here to prove that. And then explaining how the ratio can help you compare the juices was, again, what I modeled for you. Part B says the next day each of the 3 people made juice again, but this time they were making apple juice. They're asking whose juice has the greatest water to juice concentrate ratio, which would mean the same thing as what we did above. Then it says whose juice would taste the strongest. Keep that in mind when you go to answer that second part of the question, because the water to juice concentrate tells you how weak it is. The greater the water, the weaker the juice would taste. So we're going to look at Laredo's, and again, we will do a water to juice ratio, which is 12-2. Simplified would be 6. Franca's ratio is 15-6. And although that's not a nice whole number, it does come to 2 5/10. And we want to be accurate so we can compare. And finally, Milton's was 16-6. And again, it will give us a decimal, or if you're good at dividing with fractions, it would be 2 2/3 water to juice. Then they ask us to put the juices in order from the strongest to the weakest apple taste. That would mean then that the less water you have, the more concentrated the juice will taste. The strongest juice would be 2 5/10, since that has the least amount of water. So Franca's juice, in this case, would be the strongest, then Milton's, and then finally Laredo's, who had a lot more water, at 6 parts of water. You need to explain in the same way that I explained it to you, and then show how it is different from the grape juice questions. And finally, Max and Sheila were making orange juice. Max mixed 15 cups of water with 4 cups of juice. Sheila made her juice by mixing 8 cups of water with 3 cups of juice. We're going to compare the ratios of juice concentrate to water by making ratio tables, and then state which beverage has the higher juice concentrate to water ratio. So Max used 15 cups of water, 4 cups of juice concentrate, and then that would, if we made another table, that would be 30-8. And continuing on, this is Max and Sheila. was 8 to 3. Which if we double would be 16 to 6. And we could continue until they have matching numbers. However, since we were finding unit rates before, what we can do more effectively is to do 15 divided by 4 to find the unit rate for Max, which would be 3 75/100ths, and the unit rate for Sheila, which is 2, and rounded to the nearest hundredth, 67/100ths. So the stronger juice would be Sheila's, since we were looking at water to juice ratios, and her water to juice ratio is smaller. She has less water than Max has. Finally, Victor is making recipes for smoothies. His recipe calls for 2 cups of strawberries and 7 cups of other ingredients. The second recipe says that 3 cups of strawberries are combined with 9 cups of other ingredients. And they want us to find which smoothie recipe has a more strawberries compared to the other ingredients. So if Victor has 2 cups of strawberries to 7 cups of the other ingredients, then his second recipe is 3 cups of strawberries to 9 of the other ingredients. We could extend the tables by multiplying first by 2, we could multiply by 3. 3 times 2 is 6. 3 times 7 is 21. And if we look at our tables, we can see that the amount of water here in Victor's first solution is 6, and the amount of water in this second entry in his other solution also had 6 cups of strawberries. So to compare them, which smoothie recipe has more strawberries compared to the other ingredients, we would look at these entries, the 6 and 21 for his first recipe and the 6 and 18 for the second recipe. And looking at that, you can see that there are more strawberries in comparison to the other ingredients in the second recipe, since there are more other ingredients in the first recipe.